Hello. Okay, today we're going to be talking about MAFS G 2.7 and 2.8, which is all about applying the Pythagorean theorem and finding the distance between 2 points. So a lot's going to be in this video today, but we will get through it. So quick reminder, tomorrow you will have a standards checkpoint in USA Test Prep, as well as Friday. These are going to be your last two grades of the year, so please make sure you get those done. All right, our first problem here says that Lily and Matthew are walking from home to school. Matthew has to return a library book on the way and follows the sidewalk. Lily walks directly to school. Assume the path from the home to library is perpendicular to the path as the library to school. Use the lengths in the diagram to determine how far Lily walks. So when we're talking about Lily here, Lily is going home straight to school, so we need to know this path that Lily walks. Matthew, on the other hand, is going to be coming down this way and then over this way. Well, since this forms a right triangle, we can use Pythagorean theorem. A squared plus b squared equals c squared. I'd really encourage you to pause this video and try to solve this on your own. So if I plug this in, either one of these could be a and b. 1/2 squared plus 3/4 squared equals c squared. Remember, your c squared is always across from that right angle. So if I square 1/2, I get 1/4. If I square 3/4, I get 9/16. Well, these are not equivalent fractions, but I could turn it into an equivalent fraction. So I need to have a denominator of 16, which means I'll multiply the top and bottom by 4. So 1/4 is the same thing as 4 over 16. So 4 plus 9 is 12, so 12 over 16 equals c squared. So if I take the square root of this, I end up with the square root of 12 over 4 equals c. Oops, and now that I'm looking at this, 9 plus 4 is 13, so this would be the square root of 13 over 16. So if we put that into our calculator, we would have approximately 0.9 miles. All right, let's go ahead and look at number 2. Television sizes are given by the length of the screen's diagonal. Tyrone wants a new 53-inch television for his bedroom. He plans to put the TV in a spot that is 42 inches wide, but he's not sure it will fit. So 42 inches wide, but he's not sure it'll fit. Tyrone knows the new television has a height of 28 inches. Determine whether the TV will fit in this space. So first thing that's really important here is, do you see the right triangle? So do you see the right triangle? Well, I have one on each side right here. I have 2 of them. I'm cutting that screen in half. So if I were to be figuring this out, 28 inches is my height on both sides, and 53 is my diagonal. Remember that diagonal is also your hypotenuse. So this is A, B, and C. Well, what Tyrone wants to know is, what is the length of this side? Because it can only be... So the key to this problem is, do you see the right triangle? So in order to see that this is a Pythagorean theorem problem, you have to recognize that this TV, if cut diagonally, does form two right triangles, where this diagonal is our hypotenuse, is our C value. So what Tyrone is saying is that this TV is 28 inches tall. That's going to fit. But what I want to know is, what is this length over here? Because if that length is not 42 or less, it is not going to fit. So we need to figure out which value we're solving for. Well, we're going to be solving for A or B, right? Since those are the lengths. So in our formula, A squared plus B squared equals C squared, I'd encourage you to try to pause this video and plug in and see what you come up with. So if you were to solve this, 28 is A. We don't know B squared, but C squared is going to be 53. So 53 squared. So if we go ahead and we solve this, 28 squared is 784 plus B squared equals 53 squared, just 28,009. What you'll notice in this problem is that I need to solve for B. So because the 784 is on the left, to collect my like terms, I need to subtract it from both sides. So B squared equals 2025. And if I take the square root of that, so if I take the square root of that, because I have a B squared, so my last step in Pythagorean theorem is square rooting, B equals 45. Well, will this fit in the space? No, this 45 inches is not going to fit in the space because we only have 42 available. We only have 42 available. All right, so please make sure you practice these Pythagorean theorems, these application problems. The last one that we're going to look at, it says find the length of AC given a right rectangular prism. Show your work and explain how you determined your answer. So when I'm looking at this, A to C is right here. Is that going to be my A value, my B value, or my C value with Pythagorean theorem? Hopefully you answered C. So the bottom leg is 72. The other leg is 21. So in order to answer this problem, all we have to do is fill in our Pythagorean theorem. So A squared plus B squared equals C squared. So we take our legs, we're going to square them. We're going to add them up. So 21 squared, 441, 72 squared, 5,184. If I add those together, I get C squared. But remember, I'm just looking for C, so I have to square root. And when I do, my C value is 75. So take a look at your work, compare it to my work, and make sure you don't have any questions. So now the last couple that we're going to look at all deal with distance. So this says find the distance between the points J and K. So when we're trying to find distance in a coordinate plane, it is diagonal. It is a diagonal distance, which means we cannot just count the spaces. If you look, there has actually been a right triangle. See if I can get this to work for me. There we go. There's actually been a right triangle created from J all the way over to K. So what this allows me to do is actually count, because we can count horizontal and vertical distances. We just can't count diagonal distances. So if I count this, the side length here is 1, 2, 3, 4, 5, 6, 7, 8, 9. The side length here is 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12. So when I go to solve this, I'm going to use my formula a squared plus b squared equals c squared. I'm going to plug in 9. I'm going to plug in 12. So 81 plus 144. And you will be able to use a calculator on problems like these. So 81 plus 144 is 225. So if I take the square root of 225, my C value is 15. So 15 units from J to K. So 15 units. Okay. So here's what I want you to do. I want you to go ahead and pause this video. This says to graph and label PQR, whose vertices are located at P, Q, and R, and they give you the coordinates. Determine the length of each side and justify your answer. So go ahead, pause this video, try to solve these on your own. All right, so the very first thing we're going to do is we're going to want to put these points on there. So P is at -5, 2. Q is at 7, -3. And then R is at, oops, this is 6. There we go, 7, -3. And then R is at 7, 2. So the coolest thing is if we actually draw in our triangle. Let's see if I can flip this over. There we go. So if we were to draw in our triangle here, you'll notice, there we go, that we have a vertical distance and we have a horizontal distance. So from P to Q and Q to R, we don't actually have to calculate anything. We just need to count. So from P to R is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 spaces. So P to R, R to P is 12 spaces. R to Q is 1, 2, 3, 4, 5, 6. Oops. 1, 2, 3, 4, 5. I have it down one too many, so 5 spaces. What I want you to do is take a moment and solve for PQ. So to solve for PQ, we're going to use a squared plus b squared equals c squared. So 5 squared plus 12 squared equals c squared. So 25 plus 144 is 196. So if we take the square root of both of those sides, this value over here is 13. So I'd really encourage you all to go back through, pause these videos, try to solve these Pythagorean theorems on your own. And remember, you should be logging into USA Test Prep every day, practicing these standards as we get closer to your FSA. Have a great day.